So of course it stands to reason that we need a backup solution for our virtual machines. Now, traditional backup will have us run an agent inside of a guest operating system and scan an environment, a file system, for files that had been changed since the last time we actually took a backup. Okay? We'll then, whenever we're ready to do a backup, scan for those files that have been changed. We'll copy those files to a backup server, and that will be that. If you can imagine the requirements in terms of storage and CPU and memory for doing that scanning constantly of a file system, looking for files that need to be backed up and then backing those up, we can understand that those systems really chew up a lot of CPU and memory. Now, if we're running many, many virtual machines on a single ESXi host, and a single backup job would require almost all of the CPU and memory we can get our hands on, then certainly running 50 or 100 simultaneous backups on a single ESXi host would simply not work. So we have to come up with another solution. So rather than targeting a file system within a guest OS, we're going to actually target the VMDKs as they sit on the data store. So backup in a vSphere environment targets the virtual machines themselves, not the guest file systems. The way that it works is we deploy a virtual appliance in our data center that has access to a separate set of storage. We will periodically scan the blocks of a virtual disk looking for newly written blocks, and we're actually going to keep track of these newly written blocks with a system called Changed Block Tracking, or CBT. And as we keep track of these blocks, periodically we'll hit a backup time, we'll copy these new blocks to a virtual appliance, a backup system where those blocks can be deduplicated and compressed and encrypted and whatever you want to do with them, and they will be stored where? Somewhere else, somewhere other than the same storage array that the existing running virtual machines are in. So what VMware provides is the vSphere API for Data Protection, or VADP. And this allows third-party vendors to build their own backup solutions. There are, on the VMware website, a list of third-party vendors who have been certified to run their backup solutions and built backup solutions specifically for vSphere environments. So have a look at VMware's website to find those and choose one that will suit your needs. We then are offloading this backup process to a separate virtual machine, running on a separate set of ESXi hosts, if you like, in a remote site, even better, okay? Or at least a separate set of VMs in the same site. The idea then is that I don't have to chew up CPU and memory looking for changed blocks within a virtual machine itself. I can offload that to a separate system so that I can be sure that I dedicate enough resources in terms of CPU and memory and network bandwidth and storage I/O and so on. I can dedicate those to a separate set of systems. Okay, so we offload that process to this backup server, a virtual appliance, where then it can take the changed blocks, copy them down to disk or tape or whatever system you would like. The way that it does it is by doing something called a SCSI hot add. It will take a virtual machine that it's ready to back up. It will mount its virtual disks in read-only mode. By doing this, it doesn't interfere with the existing virtual machine where it's actually writing to data. It'll take a snapshot of the virtual machine, making sure that that base disk is in read-only itself, okay? Look for the changed blocks, copy the changed blocks now to the backup server, do all the special stuff it does with that data, like deduplication and compression and encryption, okay? And then release the virtual machine, okay? The snapshot is then committed. Any writes that occurred during that backup process will be written to the base disk, and the virtual machine will go about its merry way as if nothing had ever happened. No CPU activity required within that virtual machine at all that has been backed up. It's a really nice and efficient system. So the way that we can do this super efficiently is by building something called a ctk.vmdk file, or a changed block tracking file. What this ctk.vmdk file does is simply make note of the blocks within a virtual disk that had changed since the last time the VM was backed up. Then, when it comes time to back up that virtual machine, we simply read the CTK file. It tells us which blocks to back up. We copy those blocks to the backup server and reset the CTK VMDK file for the next day. So changed block tracking gives us much faster and more efficient backups, so we don't actually have to scan anything on the disk to try to discover what it is that we're supposed to be backing up. Well, that does it for a very simple and short lesson on replication and backup. We've discovered sort of the mechanisms by which we're going to do replication and backup. We are aware now of the vSphere replication appliance. We can go and choose a third-party vendor for backup, and we know how to recover virtual machines in terms of the replication as well. And we looked at those APIs and some of the capabilities. Now, all of the vendors that are building these things are going to utilize that API a little bit differently and provide you other features, perhaps for the other types of systems that you also may have in your environment. So your mileage may vary with these various vendors. Examine them and choose one that will suit your needs. Well, we've gone through a whole bunch of stuff now that looked at virtual machines and their management. And we have a lot of questions now that we have answers to, okay? And as we work with our administrators to figure out what features to use, we can actually look at a list and provide some suggestions for this process. So if I want an efficient process for provisioning and deploying VMs, what feature am I going to use? Oh, well, we can use templates, and we can use clones, and we can use content libraries. When we look at maintaining virtual machines and patching those operating systems, we can do that within content libraries, or we can simply take our templates and we can convert them back to virtual machines and manually update them. When it comes to backing up VMs, we know about the VADP systems and third-party backup mechanisms that we can do. When it comes to disaster recovery and business continuity, we can do things like replication, and if we want, we can even investigate Site Recovery Manager as an automated system for helping us with this. Okay? So lots of different things that we can do. Oh, look, they also suggest, of course, before patching and upgrading systems that we take a snapshot. Don't forget the snapshots, right? Okay, so lots of nice things that we've looked at. Backing up VMs, vSphere replication. Wow, lots of really good stuff. Take a look at some of this stuff as you're making decisions about your own environment. Okay, so that does it here for module number 7. And when we come back, we're going to have a look at performance in the environment and all of the factors that can affect our virtual machine's ability to get the resources that they need. And we'll look at ways that we can measure performance and report on performance and ensure that if we should happen to have overcommitted our environment, that we can ensure that in the event that there is contention, that certain virtual machines are guaranteed certain resources. Okay? So stay tuned, and we'll see you in Module 8 coming up very soon.